So, good morning. Welcome to this talk. This talk is about QtMozEmbed, and we are going to see how to embed the Gecko layout engine with Qt5. My name is Siteshwar Vashisht. I'm from Pune city in India. I work for Red Hat, and Red Hat I am mostly responsible for fixing bugs in desktop components of Red Hat Enterprise Linux. I'm also a maintainer of Fish Shell, and I've been contributing to the Sailfishers project from last 3 years.
Hello, my name is Raine Mäkeläinen. I hope you hear me. If not, I can take the mic. So I'm from Jolla.
So before we get into the details of what is QtMozEmbed, we need to understand the motivation behind it. We need to understand why do we need this API. And the primary motivation for having this API is that we wanted to make user interface decisions on the application side. So we needed an API that allows us to take enough information from the backend about what information to display. And how to display that information should be decided by the application itself. So for example, let's say if a web page wants to show an alert box, then the API should take information about what should be the content of the dialog box, and it should pass it to the application. And the application should display the alert box. It could be a dialog box in KDE. It could be a dialog box in Selfish Silica. It could be any Qt-based API. So why do we want to do this? Because we want a more native user experience. And we also wanted this API to be flexible, because from an application developer point of view, our requirements keep changing. So for example, let's say we want to add support for a new gesture, or we want to add support for a new browsing mode. Then the API should be flexible enough that we should be able to make those changes quickly. And none of the traditional APIs solve this problem. So we needed a new one. So what is QtMozEmbed? It's a Qt library that allows you to integrate Gecko layout engine with Qt applications. So Gecko layout engine is the layout engine used by Firefox browser. And QtMozEmbed is based on an API called Embedlite. So Embedlite is a third-party API that allows integrating a Gecko layout engine with third-party applications. And QtMozEmbed is based on top of it. And it started as a research project at Nokia. And the initial implementation of QtMozEmbed was done with Qt4 on top of X11. But with Qt5, we moved to a Valent-based stack. And we still keep improving the API. We keep adding new features into it. And we keep optimizing it. So this project is still work in progress. And there are primarily two types of APIs provided by QtMozEmbed. And that is the context API and the view API. So context is like a global API. It's used to set global options. So for example, let's say if you want to set browser preferences. For example, let's say you want to set the default download directory. That you can do through the context API. And view is responsible for rendering content. And there are two types of view APIs. And one is QQuickItem based, and the other is raw OpenGL based. And we will see them in more details in the next slides.
Okay, let's go now to the bit deeper to the architecture and how it goes. So, like in high level on the right-hand side, we have the Gecko rendering engine, and then at the left-hand side, we have Qt GUI application, the client side of it. And the application is written in QML, the Chrome. All that stuff that we have there you see in the user interface, that's QML. Only thing that is not QML is how the rendering of the web content itself has been done. So I'll show that in a minute in a demo. So application uses then the QtMozEmbed API that provides the context and the views that can be used. Also an example in the code, also like how the view goes. what needs to be done in order to get the view up and running so that we can start drawing the web content into that view. I don't go too much into details of the underlying stuff. You can come and ask from me if you want to know more about the Embedlite embedding or the integration mechanisms themselves. I touch a bit these Embedlite components in a minute and how it relates to this picture and how we integrate things. So let's give a look if I manage to too small. Manage to show the view. So we have just like a queue window here. This will be the view that this is exposed to QML registered type, and this is the one that provides the surface then for our web engine to render into. And then, as Situ said a bit about the initialization, so the context is the one that starts the engine, and it initializes the event loop of the engine. So in this example, at the end of the constructor of the window, we initialize the context of the engine. So after this phase, the engine is ready to start to work. But we also need to take care of the time that when the engine is initialized. So let's see, where is my cursor? So let's jump over here. So once we have the context ready, we set some preferences for the engine. The preferences are basically same properties that you see on Firefox on desktop. And we have some own properties as well. But once we are finished over here, we are ready to start creating the actual web pages. So in this example, I create the actual web page. Let's see over here. So I can jump over here. Okay, let's not go too much into details. This is just the normal way of creating the components in the C++. Where is the menu? So the OpenGL web page is just a queue object. And it is the one then that provides the navigation APIs for loading pages, getting information about history changes, etc. But there is one, in this example, one crucial piece that we need to get from the web page. We need to know that when we are ready, or when the web page itself is ready to render or wants to start rendering. So over here, sorry. Difficult to see. Where is the cursor? We have this is a directly connected signal, and then we are connected to the Gecko's compositor thread. And when the compositor wants us or requests a GL context, then we have a direct connection. So this is called from the Gecko compositor thread. So now in this case, we soon see that we have two windows basically there in the scene, but we have one rendering thread for Gecko context content, web content, and then we have traditional QML rendering thread for QML content. So, but at this moment, when we get this signal from the engine, we create OpenGL context and set the surface, this window for that context. And now Gecko can start rendering web content on its own to this surface. So let's jump to the QML. So we have Q window here. We have in the main. Let's jump to the main actually. So we have registered the couple of types we have inherited a bit from the MozEmbed, and then we register a couple of types. And then we have a quick view, like a normal QML thingy. How would you like to start it? And then let's go back here. So this is just an application window in practice, or it's Silica application window, but in this case browser application. And then we have a web view, which is the window for the web content. And we have a Chrome on top of it. These both things, they live on top of each other. And the web content being the background window, and the Chrome being the foreground window. And then the compositor takes care of compositing these two together at the compositor side. Yeah. So in a nutshell, that's the rendering pipeline that we are using here, how to initialize it, and then what are needed infrastructure pieces needed here. So Q window, and that's about it. And there is that quick item-based web page as well that can be used, and that can then be used directly in the scene like a normal quick item. Okay. So let's now give a look then at how the user interface integration goes. Let's see if I manage to switch to the... No? There it goes. Maybe this is covering it. Here we have it. So then the actual web prompts and such. This Gecko, or the QtMozEmbed provides an API to register, listen, and receive messages from Gecko engine. Messages are always, the message handler is called on receive async message, and it contains always two arguments, string message and JSON data argument. And we basically then handle each and every message that we have registered to be handled. Each data JSON includes window ID. The window ID is the representation of the web page that Gecko is currently using. We create UI component, and then once the UI component is done, and if the engine has been blocked, like in case of alert, then we need to release the engine by sending back a message to the engine. Like in this case, we would send alert response with the given window ID. And from this moment onwards, the engine continues execution. So how does this then look in the code? It's more or less over there, but now we see that we should, here it is. So now we see that how it's then the integration done with the platform UI toolkit. Here we use page stack concept from the Sailfish Silica. Pages are like they are full screen views that in our case in Silica they are gesture driven. So we can always wipe the page away from the stack. And in case of dialog, we can also accept the dialog with right to left swipe. So we want to have it in the platform, in the page stack provided by platform. So we push a prompt dialog into the page stack. And then once the prompt has finished, user has done the steps with the prompt, we send the response to the engine. And then, for instance, with the confirm, we do the same, but then we distinguish whether user accepted or rejected the prompt. And list could go on and on and on. Now I have here still one example, like for instance, context menu integration. But over here, we see that within the context menu, that the data varies a lot. But there is like for each message, there is different data provided by the engine. And so the API is rather low-level API. But when you have this kind of one-to-one mapping, and then you know what you are aiming at, you can cope with the low-level API as well. So that's in practice how the user interface components are being integrated to the Chrome. So let's take the next slide, if I manage. So let's give a look then how this would work or look like on the device. I have here a VNC server on the device, and then client on the laptop. So once I press the confirm, I get the platform look and feel dialog, which I can reject by doing left to right swipe, and accept by doing right to left swipe. And then the example HTML just prints out the result that we replied in those asynchronous message handlers. So if I cancel it, then it knows that, okay, now it was canceled. And in case of context menu, for instance, which doesn't use the page stack, then we have just like a normal, like a user interface component integrated and animated and whatnot on top of the web content. And these, as said, these both live in like on top of each other. Web content is always at the background, content at the Chrome at the foreground. And if you want to see more about the demo, I'm happy to demo more offline so that we don't run out of time. hopefully that gives like a little bit some sort of idea that how the integration goes, and maybe there are some ideas that you would like to pick up to something else as well. So let's jump to the summary.
So how did QtMozEmbed helped us in this case? It allowed us to integrate selfish Silica components with Gecko. Also, there was a recent change in the rendering pipeline, and the flexibility of QtMozEmbed allowed us to switch to a new rendering pipeline without breaking any existing code. In future, we should aim for raising the abstraction of the user integration mechanism, because as you saw in the code, we were directly dealing with the JSON messages which are sent from the layout engine. In future, we should write a high-level wrapper over it. Why? Because it's not considered very safe to directly deal with the JSON messages. So just for safety purposes, we should introduce a more high-level integration mechanism over it. That's it from our side. Thank you, and it's time for questions.
Thank you. So questions? Okay, we have one there at the back. Currently, we are using it on Jolla devices, but you can basically compile the Gecko with the Embedlite for desktop as well. So in practice, once it's run on top of ARM and Intel on our device, on Jolla devices, you should be able to get it to run to decent mobile devices as well. Kind of have enough power, and then you should be good. I don't know exact hardware level that what's the lowest possible. What else? Yeah. Yeah. It doesn't. It's like a separate entity, and we had at some point of time we needed to do some decisions how to and what's the timeline and so on and so forth, and then we ended up integrating Gecko instead. We started with the 4.8 on top of X11, and back in that time getting Qt WebKit 2 up and running would have required that we would have Qt 5.x only dedicated for browser, and that was the reason that it was considered to be a bit too big task to get that up and running. Servo is probably, it's going to be a different fellow, but yeah, we try to update the engine like to the Embedlite as well. And we have been updating it, and hopefully we get the next update out at some point of time. So we can take the upstream Linux version, basically, of Firefox or Gecko. Okay, if nothing else, thank you.